Hey guys, welcome back to Maths Recovery with Rebecca. So we are going to be starting something new. I am putting it out there. We're going to be doing some subscriber questions. Sorry about that. And the question that we're going to go through today was emailed to me by one of my subscribers, and this is my email. Email me your question at mathsrecoverywithrebecca@gmail.com. and I will get to them as soon as I can. Please remember, I'm only one person, which means that I will get to them as soon as I can. So if I feel like the question is video worthy, then I will make a video. If I do not, then what I'll do is I will send you, or I'll email you back, and then I'll send you some pointers and some other videos to look at that are on my channel to guide you to answering the question. I'm looking for higher order questions that would be quite difficult for anybody else to do. And what I'll do is, if I do make a video of your question, I will just email you the link that once your question is posted. Great. Okay, so this is the question that was sent to me. It's grade 12 Euclidean Geometry. What you can do is you can pause the video, try it out yourself, and then here's the answers. So you can pause the video, try it out yourself, look at the answers, see if you got it right, and then what I'll do is in the comment section, not the comment section, in the description of this video, I will put the times at which each question started in the video. So let's say, for example, you got question 1 right, but not question 2, question 3 or 4, then you'll have to just go to the description and see where I started question 2 and go from there. It'll make it easier than by running through all the questions, because if you got question 1 right, there's not really any reason for you to watch me do question 1. But I'll be running through these quite efficiently. And if you have any questions, pop the questions in the comments below. And if you have any questions that you would like me to do, please don't hesitate to email me. Okay, so let's start with the first one. So things to look out for with these questions, we're looking for common angles, same bases, and triangles between parallel lines. Perpendicular heights can be drawn from shared points. So what's important to note is that in your actual physical exam paper, you are not allowed to construct any line unless you are doing a proof, one of the theorem questions where you have to go and construct something to prove that something was true. This will be like the first Euclidean geometry question you get. Then it makes sense when you have to draw your own circle and all of that stuff. But if you're doing the physical Euclidean geometry, you're not allowed to construct. So with this question specifically, I think it was question 1 of them, I actually had to construct a height. So the textbook, wherever this came from, is not really CAPS compliant. But anyway, let's continue. So they want us to find the areas of ACE. So what I've done is I have first read the question and seen that all the parallel lines have been given, and they have been written on here, DG and EC and EF and AC. Great. And then what I did is I looked at the ratios that were given over here, and I went and I put them into fractions, and I represented the ratios in terms of specific letter. If you understand what a ratio is, you would understand why I wrote the letter T and T. You can use any letter as long as it doesn't come up in the question. Like I can't go and use A, G, D, E, F, B, or C. So these lengths have been reduced down to a ratio of 4 to 5, just for that one side of the triangle. And I did that with the other one. BF over FC is 2 to 3. There I've written it in my shape. And let's begin, because that's all the information that they actually gave me. So the first thing we need to look at is there's a lot of triangles going on here. Okay, so let's go and highlight the first one, ACE, and highlight the next one, AGD. So remember, we are looking for either common angles same bases or perpendicular heights that we can draw. So what I'm seeing is we have a common angle, angle A. Both the triangles are going through that angle. So we are dealing with common angles. So there's two choices here. We can use the theorem that states if two triangles have a common angle and the opposite side of that angle is parallel, as we can see, the opposite side here, GD, is parallel in the purple triangle, as well as CD is parallel in the red triangle, then the ratio of the areas equal the square of the corresponding sides. You can do that. Or option 2, you can use the area rule for triangles that are not right angled, which is more of the way that I would go, because we're not learning, there's no need for me to learn a whole new theorem when I already have close to 13 theorems that I have to learn for this paper. So I completely forget about that one, and I'm going to use my area rule. Okay, so let's take a look. The area rule is just half ACE. So ACE, if we're looking from this angle, we use the sides. So ACE, so it's going to be AC multiplied by AE, and then sine of that angle that is common. And the same thing over here, we're doing AG, and we're at AG over here, sine A. Okay, we do have, what do we have? We've got the length of, not length, we've got the ratio for AC, we have the ratio for, we don't have the ratio for AE, we have the ratio, we don't have the ratio for AD, but we have AG. So how do we find those two ratios? Because I know that the half and the half are going to cancel, and the sine A and the sine A are going to cancel. So what we can use is, if you actually look at the big triangle that we're working in, this is line parallel to one side of triangle. So I can go and state that AG over GC is equal to AD over DE. And that reason is going to be line parallel to one side of triangle. And that's going to mean that AD is now 4 of my new ratio. Remember, I can't use the same letter because it's just a simplified version of the same ratio. And this is 5m. So that's just my ratio simplification. Whatever it was initially divided by, I've got to multiply it by now to get my original side length. Okay, so that's what we're working with. And let's just go and substitute this back in. So AC was 9t, AE was 9m, AD was 4m, and AG was 4t. All of these variables just cancel, and then I'm just dealing with 81 over 16. And that's the answer. Great. Let's move over to the next one. Okay, so we got that answer. Let's look at these two triangles. So I've got CEF and I've got BEF. So what I'm seeing is these two triangles share this common angle. It's a shared point. So it's not the whole of angle E that is shared. It's only a shared point at E. So what we need to do is, if you have a shared point, you need to draw yourself a perpendicular height. Again, you have two choices. Use the theorem that states if two triangles have a common perpendicular height, then the ratio of the areas equal the ratio of their bases. Or you can just use the normal half base times perpendicular height and cancel what you need to cancel. And that's what I'm going to do. So I'm going to go half base of CEF, that's just going to be 3x, and then perpendicular height, which is just perpendicular height. And then for BEF, it's going to be 2x times that perpendicular height, Well, let's look. So the halves will cancel, the perpendicular heights will cancel, and the x's will cancel. My answer will just be 3/2. Great. Next one. Okay. Let's go and highlight these triangles for ourselves, GEF and BEF. Now, what I'm seeing is they have no common angle. They have no bases between parallel lines or shared bases. That's a shared base over there, but it's not really between parallel lines because it needs to be this whole triangle then. And there's no way that we can draw a perpendicular height, because if I look at this shared point, it's going to pop down here, or it's going to go up. If I look at this shared point, it's going to go here. That might be something, but let's look at something else. So this triangle CEF and BEF is very similar to BEF and GEF. You see the BEF is the same. So maybe I can relate this GEF and CEF. Maybe that will make my life easier. So there I've highlighted it in blue. What I'm seeing is they've got the same base of EF, as well as they are between parallel lines. There's the parallel lines. So the theorem states that triangles with the same or equal bases and fall between parallel lines have equal areas. So that's going to mean that the areas of those two triangles are going to be exactly the same. So let me write that in here. The area of triangle GEF is going to equal to the area of triangle CEF, that's an F. And that's going to be because the same base, same height. So that means that the area of triangle GEF can replace this area of triangle CEF, or vice versa. So that's what I've done. I have now changed the question to, instead of triangle GEF, I've changed it back to CEF. And isn't this exactly the same as question 2? So my answer is just going to be 3/2. Great. Now let's look at the last one. So this question, there was a lot going on with this question, and I was able to simplify it. I think I came up with like 3 or 4 different methods here. But this one was the easiest one for me to see. Okay, so we've got triangle CGE, and there is triangle CDA. So I couldn't find any common angles. I couldn't find any, for those two triangles specifically, any same bases, triangles between parallel lines, or any perpendicular height that I could draw to make the triangles have at that shared point C. I couldn't find any perpendicular lines there. So what I did is I went and I looked between the parallel lines, and I noticed that that triangle CDE was the same as triangle GCE. You see there's the parallel lines. So we're looking at the blue and the red one now. The blue one's a new one that I discovered. It's got the parallel lines there, as well as that base CE. Okay, so I realized that the area of triangle CDE was equal to the area of triangle CGE, and that would be this same base, same, oh, that's a same height. Okay. And that would mean that I can go and replace this CGE with CDE. And the reason why I did that is because, do you see that triangle CDE and CAD share that same base, CE. That means that I can go, I've just highlighted it more for you, the purple one, so it goes over the red one. And there, the blue, those two, we're working with those two now. They've got this perpendicular height that can be drawn from this shared point. There he is over there. So what I can do is I can use that half base times height. So half the base of CDE, so that's going to be 5m, times that perpendicular height that we found. And then I've got half the base of that purple triangle, which is 4m times that perpendicular height. And the halves are going to cancel each other, and I'm left with, well, that was drawn funky. I'm left with this 5/4. Yeah. So I actually really enjoyed this question. Okay, so thanks for watching. If you have any questions, there's my email there on top. Please email them to me so that I can analyze them and make a video for you on them. And yeah, have a great day.